मैनेट का लिंक दिया हुआ ना उसका। नहीं वो वो मंगवाया ना लैपटॉप। ये ऑफ करना पड़ेगा माइक। उधर लगा देंगे तो ऊपर आ जाएगा। बुलाओ ना किसी को, साइड में इस साइड में लगा दो, कोई दिक्कत नहीं। मतलब हम लगा दें इसको थोड़ा इधर कर सुनी।
So, very good morning to all of you. Today, this is the second day of the course, and this is the first lecture of the session. Uh, the title is Current Trends and Challenges in Data Science. So, when there is a lot of data being generated in EXPOSOME, we will be required to use the techniques of data science. And therefore, it's necessary to review the current trends and challenges in data science. So with this objective, we have kept this lecture. So here I'll take generally the basics of this data science, some data mining, data warehousing technologies, and then some. I'll give you some directions uh, for exposome data science. And in the next lecture, I'll be switching over to the major issues and how data science techniques can be used. We'll be going deeper into it in the next lecture. So today we have a very big jargon, big data. Data is being generated even in your computer. You sit on the internet, a lot of data is pouring into your database. And one of the forms, how it is coming is the cookies. So you are connected with all over the world through the internet. And when you surf on the web, a lot of data is getting into your system. So your database is growing of your own PC, a personal computer is growing. Then you can imagine how the databases of organizations are growing. Multiple employees working there, a lot of data pouring into their databases, and due to operations of the organization, every day a lot of data being generated in the organizations. And this data has been growing with the growth of high throughput technologies. And data became so large that it is impossible, almost impossible to manage it, share, process them with usual databases and usual tools. So our tools were basically database management tools, and they were not able to handle this large volumes of data. And today the concepts are more and more developments are taking place to handle this large volumes of data. So the definition which is given in various books or text or on the net is hard to capture, store, search, share, analyze, and visualize. Mainly, I'll put a general word. We are interested in collecting the data, storing the data, organizing the data, and performing manipulations on the data for our own purposes. So they become very hard if the data size becomes larger. That means our understanding of the data diminishes with the size of the data. And that's a major issue here. And you can see sheer amount of machine data is being generated today due to mobile devices, tracking systems. You have web cameras all over in the city, traffic system, in the organizations. All are covered under this. Then you have uh, RFID and sensor networks, social networks. Your social network, say Facebook, there are millions of click in a split of second. How much data is pouring into the database of social network? You can imagine. And how will you analyze it, handle it, store it, capture it, analyze it, and so on? So at every second you are having millions of clicks. How much is in the whole day? So storage, because your system storage capacity is limited. You have a hard disk of 1 terabyte nowadays in your personal computer. But if such a huge amount of data arrives, that will not be sufficient. Even thousands of terabytes is not sufficient. So they have to keep on transferring that data to some storage, secondary storage devices. Or they have to keep on increasing the capacity of their storage with the time. So this, so the size of the storage required has also become dynamic. With time, it has to change. It has to be increased. So many issues are coming up due to this large volumes and velocity of the data coming into by these social networks. Then you have video archives, commerce, coupled with additional information, and you want to analyze the data, you have certain tools for that. Then it's again, after analyzing the data, you are generating the information that again forms another set of data set. And that's again a huge data set again. Now, I give you an example. Say, if you are having 10 parameters, how many relationships you can explore? Is 10 factorial. And 10 factorial is how much? Is 4 million, approximately 4 million. So my data set was containing few entries. Say I have data set of the genes, and there are few entries of the genes, say 100 genes are there, and there are 10 parameters related with these genes, and I want to explore the relationships. Even if I take 40,000 genes, 10,000 genes, I have 10 parameters. How many relationships? Approximately 4 million. So the information is larger than my data set. So that again creates an enormous data set again. And this condition is going to be miserable when you talk of exposome. You'll be having from a variety of sources. So in exposome, you are not only taking molecular data, but other data, environmental data, toxicological data, and so on. So many things, your lifetime exposure data. So this big data issue, the challenges are going on increasing with this development of high throughput technologies and new technologies. This is what's happening. You see, cookie, a small amount of data is generated by a website, saving that in your browser, and your system starts becoming slower many times. What you do, you call the person and he will come and he will clean the history, and the system becomes faster. So much data is being stored. That small data, but how many times you visit the websites, or how many times you browse the internet, every time you are getting a cookie which is getting into your system. Now there can be there are two types of cookies. One is session and second is persistent. The session cookies are basically temporary and they get deleted when browser is closed. But there are certain cookies which are persistent, means there are some cookies which will be stored for some period of time, and that period has to be defined by you. So yeah, such cookies are basically given by these e-commerce sites to store items placed in your shopping cart and all those things they provide you. Yeah. So these are the persistent. You store the data for extended period of time, and you have an expiry date of that cookie. So for that period of time, that cookie will be stored in your computer. So every day your cookies are collecting and eating up the space of your hard disk, and your system becomes slower. Then new technology, RFID has come up, which is radio frequency identification technology. by which it's just like a grain of sand. It is used to track the items at a distance. So when you go to any mart and buy some items, so they place this RFID chips in the packaging of the products, and with the help of that, they spy on you that if you are not stealing it. That's for their security purpose they are putting up. So these tags, again, they are carrying some data which goes into the computer. So your behavior is also caught up in the computer. All the data is coming into their computer, how you are surfing, how you are picking the items, where you are carrying it, you take out the item and put back on the rack. Even that behavior is also recorded in the computer of the mart. Uh, so these chips have some unique identification number by which, and by that it's connected to reader device, and you can, with the help of that, it can identify here remotely also. So they can beam back information from a couple of inches to some 20 to 30 feet away. So all this information data is getting collected into the database of the mart. Uh, Now again, new technology has come up. You can have a dot on a printed letter, and even with this dot, you can be tracked. So further developments are there. Now they are putting those into your clothes, stitched into your clothes. So when you wear that cloth, you also have a unique identification number. They can trace you that you are wearing this cloth or not, if it is in the form of the dot. So everything is generating data. My focus is mainly on the data. So all these technologies, they are generating new data going into the computers, and again, of course, it can be a boon also, and it can be a problem also for the organization. It's both the thing. So many corporations are placing orders for this, so many RFID tags, and uh, mainly the Walmart people. Now, what is collecting all this data? These You surf on the Microsoft Explorer, Mozilla, so many Explorer web browsers, all are collecting your data. All your data is with them, and whether it is your social data or financial data or any kind of data, everything is with them. And even some unethical businesses also going on. They sell your data also many times. Some organizations, we do not know. So your data is going into the hands of the people who can use it to track your behaviors and uh, start marketing the products to you. So our financial data is not safe. All my financial status is known to these organizations. So they know my social, financial, economical, everything, all the data they are having, and with that they can do any kind of analysis and use it for any kind of purposes. This is what is happening. But again, this data, big data, it leads to a big data challenge. So again, this to all do all these things, activities, you have the developments are taking place in the field of data science, data analytics, data mining, and all these things. So all these devices are collecting your data. You are using these devices. Then you have games, GPS systems, internet service providers. All these people are collecting your data. Then this all TVs, channels, all the movie rental sites, they all are collecting your data. Then this is medical hospitals and your system. This of used. So lot of data which is being collected by these people is of use for exposome analysis also. It's not only for business purpose. So initially this was developed for the business, but now this is getting into other areas like pharmaceuticals, your research, your education, your medical science, your health science, everything. So all this data is being used now. Now you have, when you go to the hospital, they have all your data like this. Medical system, they have all your data according, your whole medical history, health history is being stored with them. And then they can have your economic status also. When you pay anything by credit card, they are able to assess your economic condition also. And then you have address, you own a house, and all those things. If that data is collected, they know what is the your standard of living and all those things, everything they are having. And this again can be collected from these sources and used for exposome analysis and all those things. So these repositories are already there, your bank systems. Now you see, I have account in State Bank of India, but the Union Bank of India and Punjab National Bank also starts uh, targeting me, because they get the data from somewhere. All insurance companies, they start targeting me. They get the data from my banks only. So this going, so all data is being shared for various purposes. So these are iPhones and all these things, they are collecting your data and all being stored in various sources. And these big pharmaceutical companies, they are all collecting data. So data, why they are collecting? This data consists of gold mine of information and knowledge. So this data is gold. So they need techniques to mine out this gold. And now how you can avoid big data? You stop paying, you pay cash, stop paying by credit card, don't use credit cards, never go online, don't use telephone, don't use these cards, data cards, or don't fill any prescriptions, never leave your house. So you can avoid this big data problem. Okay. Now, what are the challenges this big data is posing? These are the basically 4 V's. The first V is the velocity. When you go on Facebook, there are 1 million clicks in a second. So many data, so much huge amount of data enters in a 1 second in the database. So that is the velocity of the data. Then second problem is the volume. Huge amount of data is entering. Your one click has how many entries? Your name, your address, what you have written there, what time you have written there, at what time you clicked it, what comment you have made, everything. So the amount multiplies. So this volume, again, somebody else clicks, that also comes into my timeline or in my Facebook, that is also visible. So everything is coming. So how many times I get the same message repeatedly? So volume. The third V is variability. There's a lot of variation in the data. Somebody is talking of English, somebody will talk of computer science, somebody will talk of films, somebody will talk of literature, somebody will talk of songs, and so on. Different kinds of data. Variation. There's variation in the data. This again a big challenge, how to handle this variation. How many databases will you create? Or how many data warehouses will you create if so much variation is there? Because when we talk of data warehouse, it is subject cited. So if there is one subject, there is one data warehouse. If there are 1 million subjects, then there will be 1 million data warehouses. So that's the issue. And the fourth V is veracity in the data. That is, veracity is arising due to certain hidden relationships which are not known to us, or some data is missing, or some parts are missing. And the other name for this is uncertainty. So we have a lot of uncertainty, and there are tools for modeling uncertainty, but the existing tools are not completely capable. So in my next lecture, I will be focusing on how to deal with this veracity in data science. That will be my third lecture. And then we'll be taking up this part in the fourth lecture. I'll be taking up in the how to apply that and how you can do all those things. So this is the area where we are working. Basically, our group is working here in our institute to deal with veracity in data science. Then the fourth challenge is, if you have collected so much data, it should have some value. Otherwise, why should I invest money in that? So much infrastructure in that. So how to extract the value out of it? If we are collecting data of exposomes, how to extract out the real information from that exposome, which can give us a clear picture that which aspect of the environment has caused that disease. So relation of disease with that component of exposome. This very challenging, very challenging. That's what we have to do. So the next, I want that some of you should learn these techniques and start looking into this data science aspect, that's exposome data science. We should concentrate. We have huge amount of data now available. Only thing is we have to tap out the real information with high accuracy. That's what is the major challenge. So if you can look into this, we can work in this, and you can do a lot of good work in this area. So after this workshop, you can have all this, you can practice it at your home, and you can come out with some good solutions. So big data issue first is the skill. Technology cannot do everything. Technology can support you. So in real sense, you want to get the knowledge, real knowledge out of it. And technology is not capable of taking out the real knowledge. It is a support to you. But the mind, human mind, is going to play the role to extract that knowledge, to deal with uncertainty. All those things is a human mind. So it's not possible without human being, not possible without a human intervention. So it's a analytics and data science capability which is required today. Due to high throughput technologies, your biological data, molecular data has grown at a very large pace. You see, earlier, Human Genome Project, it took how many years to sequence the human genome? 10 years. It was 10 years project. And today, the human genome or any genome can be sequenced within 24 hours. You see, Beijing Genomics Institute, they have 100 sequencers working 7 days a week, 24 hours a day, 7 days a week. And they can sequence your genome and provide you the analysis of whole genome in 48 hours, and that too at a low cost. Earlier, this sequencing of human genome was being done in the European countries and American countries, and they used to charge $10,000 for sequencing one genome. And China is charging only $500 for sequencing one genome. See what is the cost, how it has come down. So this what is happening. And not only sequencing the genome, they have softwares installed, and the people working there in their institute who can analyze your genome and give you the information, convert it into information and give it to you. So this is what is happening. So this all analytics and data science capability, which is able to handle such type of things, and still more improvements are required in this area. More work is to be required. Then there are certain professional development programs going on in various universities and institutes for in the field of data science. Now it has picked up. It is picking up at a faster rate, and a lot of courses are coming up. And there's certainly a requirement of these experts, these skills. So certainly the education programs are also being promoted to fill up this gap. Another thing is the data structure. Now, if there is a variability in data, what kind of data structure will be able to store? So that's the issue here. So simple database expert, they have a structured database, relational database, and they used to start simply manipulating the data, getting some interesting views and insights, doing the queries in ad hoc way. But that is not possible now in such in this type of data, which is highly variable. Volume is also large and it's coming with a great speed also. That means the speed with which data is coming in my database, I am not able to analyze it. Even the terminology which has come up is called data stream mining. You are trying to mine the stream itself, but still you are not able to analyze till until you are able to analyze something, more data has added into your databases. And therefore, that analysis becomes ad hoc. It is of not of much use because other data has also arrived, we have not incorporated it. So all these things are happening here. So we need data structures, proper data standards by which we can have proper analysis, proper manipulation, proper storage. Then what kind of data should we collect? So when you call a data scientist, he will say, you give me your data. I have experienced this thing when people from biology come to me and say, we want data analysis. So I say, you give me the data. They ask me, what data do you want? Now, I'm not a man of biology. How can I say what data I want? What kind of analysis you want? What kind of output you want? On the basis of that, I can select your data. Even if you go to the financial expert or you come with a financial data, I'm not an expert of finance domain. So financial expert has to tell me that this is the data available, and from this data or this input we can give, and this is the output we want. Then only I can design a system for him. So these are the issues. What data? Then again, how that data has been collected, the expert of finance department or a biologist, he has collected the data according to his purpose, and he doesn't know where it is stored. Many times this happens, you keep on collecting and files, and then you are not able to see because you are not an expert how the data should be structured. So the data collected by experimentalist is also highly unstructured, or data collected by a finance expert is also not very structured. So those things happen, and then again this adds to new challenges for the data scientist to first either structure the data or look for the structures according to which you have to arrange the data and then perform the analysis. So a lot of transformations are required. So he has to understand with a domain expert of that field, and then only he is able to do the job. Then what data to collect? I think this slide is on. Yeah. The fourth issue is data volumes. So what happens is that we take the samples of the data in a representative way and then perform some analysis, prototype analytics, and we get some reporting out of it. So we don't look at the whole data set, we take the sample out of it and perform analysis and come out with this. Even in your molecular biology also, if there are 40,000 genes available, you are not going to work with 40,000 genes. So what you are doing, you are selecting some genes out of it. And then you submit a paper, then your expert says, what was the criteria for selecting this 100 genes out of 40,000 genes? He asks you a question. What is the relevance? So those things happens here. So when you have a representative, you cannot you have certain constraints of infrastructure also. So you cannot take all the genes for analysis. So due to the constraints, you select out of it and you develop some criteria, and that criteria may be good or it may be bad also. So it's not a complete representative. And that is another issue. This happening due to these data volumes. Since we cannot process all the data volume, we are taking sample out of it. But the real thing will be when you have the whole data set. Then only you can give representation for every individual. If you take the salary of all the people and take an average, the average salary is not complete representative of the economic status of any place. There may be a big gap between the two people. One cannot afford even a cycle and one can afford a car. So that's the issue here with the data volumes. If you are averaging it or aggregating it or taking representative. So, and the fifth issue is the data technology. The technology is not sufficient. There are some technologies reported. Hadoop is in batch processing mode, basically on large scale operations, aggregation, counting, but it's not real time, it's not dynamic. Many times we want the results in real time or in the dynamic situations. So we are not able to, because when you require large amount of processing, it will certainly take time and you do not have infrastructure. Everybody cannot have a supercomputer. So today you have a lot of things going on, developing clouds, and you can submit to the clouds. Again, the clouds are being shared. Then also the submission time and then output time, then it comes to you. Again, those things are coming. So technology is an issue for this kind of processing. You cannot have that at your doorsteps, everything of that level, and then resources. A lot of money is invested to collect so much data. You collect all the exposomes. You spend a lot of money in the infrastructure for that. But how will you get the actionable knowledge, real information and knowledge from out of that data? That's a big challenge. Am I able to associate the diseases with the all lifetime exposures or some lifetime exposures accurately? That's a big issue. It's not easy task. So same thing is with these people also. Business people, they use marketing intelligence or business intelligence. So they are not experts of that. Internal people are not experts of that. What they do? They outsource. When you outsource, what happens? Your data is going in other hands. Then another security issue is there. He can misuse your data. So all these things are there. And then second thing, when you outsource to the people, suppose you are a molecular biologist and you're outsourcing your data to me and I'm a data scientist. So I'm not a biologist, so you have to explain me the things. I cannot work without you. So you need internal people also. Your external and internal both are required. You cannot rely completely on the external people for your analytics. So it is both ways. I can do the analysis of your data using my statistical techniques, but I cannot perform interpretations in terms of biology. You are a molecular biologist, so you can perform the interpretations, what is happening. So this is what is the situation. So resources, you need external people, you need internal people. That's why you see today in the interdisciplinary research groups, you have people from various disciplines, various domains working together, and that leads to a fruitful research or fruitful outcome. So that is another issue. So in the nutshell, we are back to the three levels: data, information, and knowledge. The objective is from data, we want to generate information. From information, or from the data, we want to generate the knowledge. So yesterday I've already talked about this. I'll not go into details. Now, when we work on data level without using intelligence or little intelligence, we talk of databases. Then, now, when we perform the operations of the organization, a lot of data is entering into our databases. So our databases are ready. They are all having structure and all the data is there, but the variation of the data is a big problem in that. And your existing structuring of the data given provided by the database management system is not sufficient to handle it. So people started looking for data warehousing. You structure the data according to your subject, your objective. Organize the data according to your objective. That was the main theme behind data warehousing. So what happened? Heterogeneous and inconsistent data uh, was heterogeneous and inconsistent as a result of piecemeal uh, development system. People in finance are not concerned with marketing, so they will not uh, take care of marketing data. They will take care of only finance data, and all finance data. So the data of finance will be in the language of finance, and the data of marketing will be in the language of marketing. Their language is different. So it was a piecemeal system development. And second was that everyone wants to optimize his own goals. A marketing department person will optimize the goal of marketing department, and finance person will optimize the goal of finance department. So according to that, they are arranging their own data sets without any interaction among the two. So their goals may be in conflict. If the goals are in conflict, again, it's not going to give you the results. So the purpose was data warehouse was to consolidate and integrate the data from variety of sources. I mean that data from marketing and data from finance should also be integrated. So there is some communication among them, and accordingly the goal of the whole organization is optimized rather than optimizing the individual goals. So this integration issue came up, and then second, the data was in different formats, different language. So data warehouse is basically the subject cited, integrated, time variant, non-volatile collection of data used in support of management decision making. So you have subject cited, say patient database, student database. So this way they started creating the data warehouses. All the data of students in one, all the data of patients in one. So everything related to patient will be in a patient database. Everything related to student will be in a student data warehouse. And all the data of that student or patient will be collected from various sources and put into the one single repository, which can be managed easily. So this was the idea behind this. And then that data has to be time variant. Data of 1991, data of 1992, data of 1993, so on. So you have time dimension also. And the fourth thing is it's non-volatile. Once the data is entered into the data warehouse, it cannot be changed by the user. Only administrator can modify if he finds something mistake, but the user cannot change that data. So this was the main theme behind the data warehousing. So data warehouse is subject oriented, integrated, time variant, non-volatile collection of data. And this was applied in the business. And now you can see NCBI website. When you go on the site, it will ask you which data you want. So you say, you click on the browser, you'll get a whole list. Gene database, protein database, so on. So many options are given to you. So pop-up window, you'll get so many options. Those they are what? They are basically data warehouse. All the data related to genes is in a gene data warehouse. And these have been integrated by putting on links. Okay. So that was another issue later on when databases grew up large. All the biological databases, where they grew up in size, the another issue which came up was integration. So I'll come to integration later on. We'll talk on that later on. So this is integration. Now here integration means all the data of genes is integrated. That means the data of genes of various species, all the species is there when I talk of genes, whether it is bacteria or it is plant or it is Homo sapiens. Okay, and I can have sub data warehouses for Homo sapiens, plants, and microorganisms, and so on. That's another way one can think of this. So Then time variant and non-volatile, I've already explained you here. So integration was in the sense within itself, within a subject itself, whatever heterogeneity was there. So integration was within a subject itself. But now today we are having problem of integration of various subjects. So that's I'll take up later on that issue. So this is all. I'll not go into this. I've already explained earlier. There were first the operation systems were defined to run the operation of the organization. Then later on they found a lot of data is generated, so they started developing information systems. So yesterday I already talked on this too. Then when you talk of operation systems, they use the current basis, current data, and there they use the past data basically just for decision making. It's past one. So this is current, this is historical data, that's past one throughout the period of time. So here we talk of state of business, there we talk point in snapshots. What is the status on that point? Here basic users are clerks and salespersons, they are managers and business analysts and so on. So they use intelligence, they basically the differences of intelligence you can see. That's here the queries are very narrow and simple, whereas their queries are broad and complex there in the information systems. And here the design goal in the operation system is performance. We want real time dynamic systems, whereas in information systems we are interested in ease and access of use of that information. We want to use the information, that's all. So according to that, so these are the architecture, two-level architecture. Your data is stored in various sources. The sources may be file, external, internal. You are picking the data from many sources, perform transformation, integration, and put into one single repository called data warehouse. So this is the whole process. I'll go to the three-tier architecture first. So this is a three-tier architecture. I have the data from various sources, collect it, transform and integrate, put it into single enterprise data warehouse, and then perform selection and aggregation. You have data marts. I give you the example, say you have a database NCBI. On NCBI, when you go on the site, you have to give the query, you want data of what? Genes. Genes of what? Cancer. So you have to go on which database? Gene data warehouse. Now gene data warehouse consists of all the genes. And then you have to select. So in the gene data warehouse, the genes of microorganisms may be a separate data mart. The genes of Homo sapiens may be a separate data mart. The genes of plants may be a separate data mart, and so on. So that's why this can be done. So when the data warehouse becomes huge, then this technology was preferred. So here again, now this has two advantages. The first advantage is that you are searching for something. Either you search in the whole data warehouse or you perform searching in a data mart. This is a smaller set. So your time efficiency improved. You require less time to search here rather than searching the whole one. And the second is the security. Why should I give the access of financial data to the marketing people? They're not going to handle that data with care. So they should not be able to access the data. Marketing people should be able to access the data from their data mart for marketing, and the finance people should be able to access the data from the data mart for finance. And they cannot access each other's data, because if our data finance goes into the hands of the marketing, he can compromise that data with somebody also. So that's a security issue due to which this was done. So this is a three-tier architecture, same I put in another slide. You have enterprise data model. So you have data from operational systems. You have metadata. Metadata means dictionary. What data is stored in this? This data is put into the data warehouse. The data in the data warehouse is a reconciled data. And then metadata means the dictionary of what is stored here. And then from here you can have derived data put into the data marts. That means you have selected and arranged the data according to your own language. say language of finance or language of marketing, and you have put a data mart for them. So it is easy to understand for them over here. So this is the three-tier model. And then reconciliation of the data is done. You capture the data, then you scrub the data, you transform the data, and then load and index the data into data warehouse. So this whole process is called reconciliation process. So so you capture, scrub, transform, load, and index. Now we'll go into this quickly, and I'll move to the next topic in this. So this I've already explained you. Operational systems. Then metadata I've already explained you. Derived data I explained you. So data is basically transient versus periodic data. Transient data is that data in which you make changes in the existing records. You can overwrite them. So you write the records are written over the previous one. You overwrite them, destroying the previous one. So basically, operation systems have such type of data. Whereas periodic data is data which is never altered or deleted once it is added to the database. So data warehouse has periodic data. Data warehouse is updated periodically. Then data may be detailed rather than summarized, so that you have maximum flexibility to use the data. This I've already discussed earlier. If you take only representative, that's not may not be a proper representation of the data set. Historical, you have a time dimension in it. Then data is normalized. This normalization is not database normalization. This is a normalization which provides you the scale in which you can compare the two data sets. If you have a graph in the scale of 0 to 100 and another graph in the scale of 0 to 1, how will you compare them? So to compare them, what you have to do? Divide all the quantities by 100 in the first graph from 0 to 100. It is converted into 0 to 1, and then you can compare easily. So which is in which the variations are faster, that can be seen only when they are on the same scale. So that's normalization. So such type of normalization we look for. Then data has to be quality control. That's another issue in this. Now you capture the data by two ways. One is static capture and second is incremental capture. Static capture is that it's a snapshot of the data set from the database. All the data in your database is collected and put into the data warehouse in one step. That's a static capture. And so this is done initially. When you are creating a data warehouse, it is done initially. And then you go for incremental capture when you are maintaining your data warehouse. So data which has been collected up to December 2017, it will be put once in the data warehouse. From January 2017, 18 onwards, every month I'll pick up the data and put in the data. That's periodic capture. Incremental capture. So every increment I capture and store in my data warehouse. So this is the way updation is done here. Then scrubbing of the data, generally it happens misspelled names and addresses, or impossible or erroneous dates of birth. This thing happens in our when you type something, and so those errors have to be removed. Maybe data may be contradicting many times. So mismatch address and area codes. This is contradicting data. So this is not correct. So you capture it and correct it. You scrub it. So all this thing is done with the help of AI techniques. For example, when you are typing in a Microsoft Word, if you misspell anything, what happens? A red line comes or blue line comes, and then you can click on the right mouse and you can see the close words, and with the help of them, what happened? It's not moving. Yes. Then you transform the data according to the language, according to the structure of your central repository. You are taking data from different structures and putting into a single standard structure. That's transformation. And then you load and index your data. So you can have it in a load, refresh mode or update mode. In the refresh mode, you rewrite the data over the target data, whereas in update mode, you only add the changes which are taking place in the data. So this way, we move. These are the tools which are used for data reconciliation. I'll leave the slide for you. You can look into it. I switch over to the another level is data mining. That's knowledge level. Now, this data warehouse is for informational purposes, and again, you need more analytics here. So we look for data mining. Now, what is data mining? Data mining is knowledge discovery from large databases. This is one of the common definitions given in the books, although there's no perfect definition to it here. So many definitions have been given, but something is missing in every definition somewhere. I'll give you an example. You can go through the books in these definitions. And then knowledge discovery is a knowledge discovery from large databases. That's the most common definition which is given in the books. Yes, automated knowledge discovery from database. Now this definition, first definition which I gave, is misleading. The word automated is misleading. Now, why it is misleading? You have 10, in your database there are 1000 entries and you have 10 parameters. And how many relationships you can explore among 10 parameters? Approximately 4 million. Now you cannot see the 1000 entries, how will you see 1 million? So if it is automated, it will give you 4 million entries. Now here the human intervention is required, which are relevant and which are irrelevant. So in that sense, this is not automated. You have to decide which are relevant and which are irrelevant. And you have to spoon out. So what data mining is not OLAP, it's not other querying. This is another way understanding data mining. That means the simple structured queries, they require very little amount of intelligence and they do not qualify as a data mining query. OLAP queries are basically online analytical processing, you call them. In that you have analytical tools to study the relation between the two parameters. What is the relation between sales and tourism? Or what is the relation between smokers and the accidents? What is the relation between drinkers and the accidents? And then you say that 100 people were found to be drunk, out of which 80 met with an accident. So what is the interpretation you give? If you drink and drive, there is 80% chance that you will meet with an accident. So such type of things, they come under OLAP querying. So this query also requires some intelligence, but this intelligence does not qualify for a data mining query. So data mining query, you require a high level of intelligence, and you look for the trends and patterns and relationships out of the whole data sets for that. So there's a link between, even you can perform data mining on the database directly also, but if you perform data mining on data warehouse, it's more economical and more useful, more easy and more economical, because this provides you the data definition and data structure readily available for mining. Whereas on the database, data may not be very structured and it may create problems in data mining. That's the issue here. So this is the link between the two. So if I go at the information level and then perform, look for the knowledge from that information, that makes it more easier rather than directly from the data you are trying to take out the knowledge. So that was the issue. So data mining is confluence of multiple disciplines: database technology, mathematics, statistics, machine learning, information science, other disciplines, visualization, and so on. So Walmart is one of the pioneering leader in this area of data mining. There were 2,900 stores in 6 countries, and he was transmitting 7.5 terabyte data warehouse, and he allows more than 3,500 suppliers to access the data and perform analysis of his products. So this was the level. But today, when I talk of biological database, it is something more than that. It's much huge. Or if you talk of social networking, it's much, much larger today. So that's a big data. That time, this big data was not there when we never talked of big data when I prepared this slide. Now, these have two types of processes. One is confirmatory analysis or verification driven. You have a hypothesis, and then from the data you have to confirm or refute the bottleneck. But the major problem is shortage of hypothesis. For example, I have a hypothesis that uh, exposure to tobacco or smoking can lead to cancer. This is my hypothesis. Now what I require, I'll collect the data of all the people who smoke, and I find out how many people have cancer out of it, or at what stage they got cancer. So I have a hypothesis and I verify from the data sets. This is the way we are going to do in the exposome analysis. So we are going to look into different components, your lifestyle, the effect of lifestyle on your obesity. Again, you can take out from this. So these are the things which are happening. So this is called confirmatory analysis. You have hypothesis and you look for that this can lead to your bad lifestyle. You are not eating at time, and you are not sleeping properly or sleeping at a proper time. It is leading to obesity. So all these things have some relationship with obesity. People are predicting, and then they are confirming also using data sets like this. So this is verification driven or confirmatory. And the second type of analysis is exploratory analysis or data driven analysis. So here in exploratory analysis, it discovers a suitable hypothesis or to confirm or refute it. First, it will explore the hypothesis and then confirm and refute it. So here I give the example, recent projection exposome, helix, exposomics, and then there are some projects in USA also. They are, USA, I saw on the website, they have identified 85,000 toxic chemicals. Now, if I have exposome of the people and how many people are exposed to which kind of toxic chemicals in their life and what type of diseases they had contracted. So all that can be done with the exploratory analysis. You explore from those chemicals. So they have explored that these chemicals are not good for health. The exposure to these chemicals for longer periods of time is not good for health. What are the effects at the molecular level, and on some experiments they have performed, and accordingly they have identified and classified those toxic chemicals which are in the environment. So this is exploratory analysis you can do. So system takes the initiative. You are looking for cancer. If I type cancer, and cancer related to which toxic chemicals, that's exploration. You explore. So it's a kind of method is called profiling, okay, or clustering. I'll come to that point again later on. So exploratory analysis. Now these were the early tools which were being used in data mining, decision trees, rule induction, neural networks, and data visualization. So these are the primary tools which are used in data mining, and this I used to teach in 2000. So that time I prepared this slide. So these are the basic tools that time we used to take. But now you have a lot of new things. So the type of information which you can get from data mining is association. If somebody comes to buy milk, what he buys in association? Bread. If somebody buys butter, he also buys bread together. So you find that milk and bread are kept together at the store. Whenever you go any store, they are kept in one place. So there's a knowledge of the shopkeeper about the customer, his behavior. that how he buys. The same association rule mining people started applying in your molecular biology. Which genes are associated with cancer? BRCA gene is there, but there are some other genes which are not there. The gene doesn't expresses. So BRCA gene will express in association with which type of genes? This association rule mining. So mining associations today in exposome, they are working on mining exposome wide associations. The association of various components of exposome with diseases. What component of exposome is associated with which disease? This is the area where a lot of scope is there and people are exploring. So you can make use of these data mining techniques here in this, and I'll explain you, show you if possible. Our MTech students, they have developed a software for association rule mining in our institute, and that software is different from the softwares which are available for association rule mining. They have incorporated how to handle uncertainty in that association rule mining. That's the improvement we have done, and they have done in their dissertations. So if I get those students, then I'll ask them to show you sometime. So uh, so association rule mining. The second is sequence of events. Again, this sequential binding. What sequence of events leads to a disease? This can be another kind of mining which can be applicable in your exposomes. So here, the shopkeeper, he always thinks that if somebody buys house, what is the next item he is going to buy? Furniture or refrigerator or uh, air conditioner. So depending on the person's behavior, they are ready for marketing those items to the people who have bought a house. So that's a sequence of events. So a sequential mining. In your molecular biology, we perform sequential mining to understand the similarity of the sequences, the structure we want to predict from sequential mining. Those things have been already applied, but same thing can be applied now on your exposome. But exposome will provide you more challenges than this. This is very simple now, today, for us. But at the exposome level, the data will be much, much complicated because it will have a spatial dimension as well as a time dimension, and many things are there. So this will be something different. So again, we will have to modify our techniques to handle them. Then it's a very common activity, classification activity, where the business people also do it, or you are a biologist or you are a scientist, you always do this activity, or in a real life also you classify. So classification is a common activity. Again, this is one of the common data mining activity nowadays. And then clustering. Now, what is the difference between classification and clustering? Classification is like supervised learning, and clustering is like unsupervised learning. This exploratory technique. That means, suppose you have the profiles of the customers, you can just, in clustering, you don't have to give any criteria for it. Whereas in classification, you have to give the criteria. In classification, I want, say, rich customers and poor customers. So I have to give the value that if income is from this much to this much, then he is a poor customer, and if income is above this, then he is a rich customer, VIP customer, and so on. I can classify that way, but I have to give the criteria. But in clustering, what will happen? It will automatically start exploring your profile and start arranging the data according to the similarities of the customers. So, say it will pick up a cluster for smokers. So all the customers who smoke, they will come into that cluster. A cluster of drinkers. Now there can be overlapping also. There may be a person or a customer who drinks and smokes both. So this cluster will overlap also. So it explores according to the properties, characteristics of the customers automatically. When you give the clustering, you don't have to give criteria, but here it. So again, this is a very common activity which will be applicable in your exposome analysis. You want clusters of particular disease. So I create a cluster for cancer patients. So what are the exposomic characteristics which are associated with that cluster? All that will come into that cluster. So these are there. Then forecasting, predictions, uh, whether the customer will renew subscriptions. This is again a very common activity people do. You try to forecast what is going to happen next and so on. Stock market, this all again forecasting examples. So basically business people, they try to understand buying patterns, fraudulent patterns of credit cards. And on similar patterns, we can also find applications for your exposome and biology. I'll come to that later on. This is just I wanted to give you information. What is the kind of this? So they use demographics, economic status, geographical details, and all this. Now this will be also be useful for your exposomics also. Now it is useful for business people as well as your exposomic analysis also will be there. So there are three classes of data mining activity. One is discovery, process to hidden patterns without predetermined idea or hypothesis. You don't have any hypothesis about it and you are exploring it. Second is predictive models. So you make use of patterns to predict the future. What happened in the past, the trend. What was the trend of share market for last 20 years? And then what is going to happen next year, I based predict on the base of the past. And the third is forensic analysis. You use extracted patterns to find anomalous elements. For example, you say he's a sportsman and his age is 90 years. I cannot agree that a 90 years person will be a sportsman. This anomalous element. So I take out that is. So this is based on the threshold. I use norm, deviation, some statistical techniques I use to identify those anomalous elements. Again, this can be one of the activities in your exposome analysis. All this will be applicable. So this is three classes of data mining. Executives who spend less than 30 minutes on the computers and take the help of analysts. Yesterday I've already explained the top executives, they form the policy of the organization. They work with the knowledge. They don't see the data, they only see the trends and patterns, and on the basis of they decide. So to get the trends and patterns, they need the assistance of end users and analysts. The second is end users, they can perform some analysis, say market researchers, scientists, and all those, they come under this category. They also use knowledge or explore knowledge out of it. And the third is analysts, again, they want to interpret the data, they do occasional computing. So again, they make use of help of other people, domain experts, to perform all these things. So in our research, we come under these two categories, analysts and the previous one. These are the two categories under which we scientists come into it. It's basically a collaborative nowadays mostly. So the people belonging to the group belong to these two groups, last two groups. Then episodic mining and strategic mining. So this again a class which can which business people are using, and again it could be or administration people are using, and which can be again used in our exposome analysis and what I was looking yesterday at it. So episodic mining means you look at the data from one specific episode. Let's take an example. In my institute, I give an application for leave for 5 years. What the director will do? He will assign the application to a clerk and ask him to find the past cases in which 5 years leave was given and put up the rules. The clerk will take out and he says that in the past the leave for 3 years was given and the rule is that maximum leave can be given for 2 years. So there was exception also that leave has been given for 3 years, but the rule is that you cannot get leave for more than 2 years. This is an episode. So what are the basis that when the rule is that you can be given leave for 2 years, but the leave was given for 3 years, what is the basis for that? Can that basis be extended to 5 years or not? This is what the director has to do. He has to use his wisdom. So this is episodic mining. The high court judges, they give judgments based on the past episode. What judgment was given in a similar situation in the past? So they cite the past judgments also. So this is a episodic mining. So it has a lot of applications in law. It has a lot of applications in detection of crime. Police department uses episodic mining for detection of crime. And again, you can also look for episodic mining in your exposome, also exposome analysis. You can look at that way also. So this another project, it can be a project, episodic mining approaches for exposome analysis and so on. The second is strategic mining. You look at the larger data sets to gain overall understanding of specific measures, say profitability. Where do our profits come from? Now you have a large data set, and from that you want to get out the sources. So same way, at present, whatever activity is going on all over the world in exposome analysis, they are looking for what are the sources of diseases on the basis of exposome. They are trying to look for sources of diseases based on genetic factors and based on non-genetic factors. What are the non-genetic factors which are leading to diseases, and what are the genetic factors leading to diseases? So this is the way one can look at strategic mining. And the third is continuous mining. How the world has changed throughout the past period of time. So how the exposome has changed. So again, you are having a lifetime exposures. How the exposure has been changing, and accordingly how his all the exposomic profile has been changing. That's another kind of mining. So again, it's a confluence of multiple disciplines. So choose your method carefully. This is very important. It should not give misleading results. That has to be taken care. So data mining should not be done for the sake of data mining. It has to be done for the sake of obtaining appropriate results. No panic here. Use your judgment and ensure the data appropriateness and its quality. If there is garbage in, then garbage out. And then always try to validate your results. There are approaches, experimental approaches are already there. All the experiments are very expensive. Then people are devising some theoretical approaches also to validate it. So you can validate by some theoretical approaches or experimental approaches depending upon your requirements. So the approaches for data analytics today, they comprise of statistical approaches, AI and soft computing approaches. A lot of work is going on this. Numerical approaches, optimization approaches, graph theoretic approaches, and the combinations of all these. In different situations, different approaches suitable or applicable, and there are combinations also which are applicable. So there are a lot of things going on in this. Those who want to work on pure computer science, they can go this side. Those who want to go for applications, they can look for exploring their combinations and find out the actual one. So exposome data analysis, I'll conclude in 5 minutes now, another 5 minutes. I think tea is ready. Tea is ready. Check. So the exposome data analytics, you have GWAS. At the genome level, people started looking for genome-wide associations, and the software was designed GWAS. What genes are associated with particular type of disease? This type of work they started, and genome-wide associations, and they were able to get some insights for the medical science, but this was not sufficient. Then they also started looking for PHIVAS, phenome-wise associations. And there is a big gap between GWAS and PHIVAS. But there's a shortcut that they try to map from GWAS to PHIVAS. That means which genomic associations lead to which phenomic associations. This is what they try to perform mapping but this mapping is not really accurate, but it gives some insights, for the medical science here. Later on, now people have started talking of EVAs when exposome they are working on. So environment-wide association studies, you may call it environment-wise or you may call it exposome-wide. Both terminology are being used. You go on this net, you will get all these things. The basic idea is to associate exposures with the disease. So this is a big area now which is going to come up, and a lot of potential is there, a lot of work is there, and this work can be done with different perceptions and different angles. And to deal with that, and these different perceptions and different angles are the cause of uncertainty. So in my next two lectures, I'll be concentrating on how to deal with that veracity arising due to the perceptions in this mining. So association mining. So that I'll be focusing on association mining in the next two lectures and the tools to deal with uncertainty in this. So finally, what are the open challenges or issues or problems? Due to variability, it's leading to high dimensionality of the data. And if the dimension increases, is a challenge to handle. Second is large volume of the data. I've already explained what is the impact of that. Then the large velocity also I've already explained. Then data location. Data is located at different places and you have to connect them and integrate them. Then many times what happens, there is a data skew. You are performing analysis on one database, but the real data is lying in another database. So there is a data skew. So this is not true representative. So collecting data. So in distributed processing also, some real data is lying in one database and the other data is lying in another database. So the processor, which here is more busy where the real data set is there, and the processor where the real data set is not there, then it's not so much busy. It will keep on rejecting quickly. So the difference is there. And then the dynamic load balancing. You have data in one database, you have large database, another database, you have a small database. So for distributed computing, again, this issue, load balancing is issue. And the veracity, I'll be talking in the next lecture. I'll deal with in detail there. The main challenge is rule discovery. You generate the relationships, but how the relationship has to be converted into rules, that's another challenge. Then people have started working on, they worked on parallel algorithms. They are developing parallel processing. That's certainly a requirement. New tools are required. And then it's generalization versus specialization. When I specialize, I'm more powerful, but my scope is limited. And when I generalize, I'm less powerful, but my scope is larger. So I have to compromise somewhere between generalization and specialization. This is what is and today we are looking for integrative data mining. That's a major issue when you talk of exposome analysis. So with this, I thank you all for patiently listening. These are some of the references. If you have any questions, you are welcome now, or you can ask me outside or in my room. Whole day we are available here. So thank you very much for patiently listening. I think he is ready. So we'll go for the second lecture, start for the second lecture. So yeah. So now Professor Patricio is going to deliver his lecture. I think your lecture schedule. You know the title?
It's big data for exposome.
So you can tell your lecture.
Thank you.
Thank you very much.
Thank you. I wait a moment. Well, sorry. Okay. probably is in some folder.
So this lesson, no?
Lesson 2.
Lesson 2.
Yeah. Okay. Yes, this one. Oh, came back. Good morning. My second lesson is very narrow to the lesson of Professor Balsani. The previous lesson has very well explained the structure of big data and the machine data mining and the general framework that of the instrument that we can use for exposome. I recall something that are that define the big data. The 5V that was previously described by Professor Baldassani, and in particular, I would like to focus. It's not important to recall what is the meaning of this 5V, but I would like to focus your attention on 2 points: the velocity and veracity that will be explained in another lesson by Professor. Velocity from an end user point of view is very important because in molecular biology, as many of you can have tried, the speed of upgrade of different molecular database is quite different. If one considers as an example the difference of upgrade of a genomic database compared with the proteomics and structural database, you can see you have a direct experience that for 10,000 genes per month, you can have one structure or one sequence of protein per month. Then the speed in which these data are produced and stored is very different. More different for other things, for the toxicological study, because of 4 other important information for exposome. What is the effect? The effect is then you design an exposome project, you have the information, you can extract the information from different databases that are a different time of updating. Then you can work on different level of data. You can, for instance, in order to perform specific correlation, it's can be a limit, because I can make some association today. Tomorrow, for instance, this data or the annotation are removed because the data are not well controlled. Then this is a limiting factor in terms of application of the process for data warehousing, because in this case you can have some data gap in your local storage or in your data in which you are working. Variety and the other topics has been very well described in a previous lesson. Well, as you can, I have recalled the definition of Gartner of big data, and what are big data for EXPOSOME is quite clear, because the complexity and the number of database and different information that must be integrated in a predictive way. We accept in this case the idea to predict the effect on long-term exposure originated by different pollution sources. And this is a standard definition of big data, and the big problem is to extract information that has a value for your specific application. As the professor has explained in previous lesson, economy, finance, biology, pharmacology, what you want. Obviously, the organization can be, this data can be organized on a different server, distributed or centralized, cloud clusters, RAIDs, or what you want. And one of the more suitable way is the cloud computing. But this approach, almost for some specific application, has a great limit. It's not a limit of power. It's a limit of cybersecurity. In the EXPOSOME, we arrive to merge together data coming from anonymous information, such as protein, genes, toward to individual and personal information, health record, social status, and so on. Then it's possible that a cloud now very well secure, that some hackers, there is the possibility that this kind of information can be removed. Or this problem is also for pharmaceutical company, because they have different departments in different countries, and they are connected by different clouds, a specific cloud. Do you imagine what happens if someone can go into the cloud and hacker and extract information about the experiment? Then this is one, from my point of view, for EXPOSOME, is an additional problem to the other problem, to the intrinsic problem of the data. Okay, according to classification, big data can be originated by different sources, such as web. In general, web record are unstructured textual information, images, or mainly you consider Google. There is the text and then the images. Sensor, for instance, if you consider a network or system to monitoring water, sea, or what you want, with the satellite or fixed position. And transaction are objects in the database that can be extracted and put it and became data for another process. For instance, the information about bank or database of movies or what you want, you can pick the record as a transaction, as a record, as hold the record, okay? Even taking the reconstruction into account. Data format can be structured if the entry is follow a specific organization, so, structured query or other types, semi-structured, but I guess one of the more interesting is unstructured, because there is an fixed format of the document, of the record, but however, it can be very flexible. In this class, in an EXPOSOME perspective, are included all the medical record. Medical record are a description by writing of the clinician, the diagnosis on a magnetic resonance, some information on the biochemical record, and also the information about annotation of proteins, of genes, and so on. The data storage can be organized as document, as graph, or by key value. All these things must be considered in the phase during the planning, during the design of possible suite for exposome analysis. The choice must be strongly related with the machine learning and data mining tools on which that can be used to analyze this kind of data. Because a failure or some problem in this phase of project can reduce the performance or can create some bugs during the execution of the program. The data pre-processing has been obviously extensively described by Professor Sardani, and there are normalization, transformation, and cleaning. Only note on normalization. There's a very specific note on normalization. The people that work on microarray can have different types of data normalization according the aim of their analysis. A normalization for SNPs is different from the normalization from expression. Then it's clear that is in order to create a database of microarray for exposome, it's very important to understand what kind of normalization methods has been used for microarray. It's very specific. There is a specific book. If someone is interested, I can give you the title, because it's a primer for microarray normalization, only for normalization. The last is data analysis can be performed in real time on batch. Obviously, real time can be the better way, but probably the amount of data and the complexity of the tools for analysis, a batch process could be more effective and more suitable. Key step in the data, big data organization. Data curation, there are three main steps: the data curation, the data stream, and the semantic data integration. The data curation is the organization integration of collected data. In the previous lesson, as the professor talked about the information, the data contained in a specific database. The curation is very important. The curation is performed by human. Consider UniProt of NCBA or NTREX database. The UniProt as a team that controls the curation of protein. Obviously, if the curation is good, you have a reliable unstructured information. If the curation is quite weak, the information that you can use is not so reliable, and you must control it. The second is the data stream, is the analyze the evaluation of the channel and the capability of data transfer from different database. Obviously, someone can have it directly tested when one attempt to download sequence from a large number of sequence from a database. You must use a batch system, because the capability of the channel of the server or the system is not enough to manage all the data that you have requested. The last, that is also the most important, is the semantic data integration. In this case, is finding the conceptual relation of the data inside the data, the conceptual level of information masked or hidden in the data that you have done. This is the top level of the exposome, because this is the step that require the finding the logical relation, the conceptual relation between a set of information from different pollution sources and disease, or in a more general way, in environmental sustainability. The semantic data integration is the true challenge for exposome, because you, at the end of the history, at the end of all the tools that the professor has described, or the combination is given to you in the next, in a predictive way, the system must give the concept between, there is the possibility that some pollutants in the next 10 years can induce this kind of disease. It's very challenging. Now, I would like one way to manage a large amount of data is the possibility to use the workflow systems. A workflow allows us to perform the same operation, the same sequence of operation on the same databases, or you can extend more times. You have when you have decided to download, for instance, a sequence from multiple databases, you know what is your query. You can program a workflow, and you cannot restart by hand to digitize the query to remake by ability the second sequence. You can run this program, and this program can make the search for you. The manager, a workflow, is implemented as a program and a programming paradigm, and in which each operation and a control step are included. You must, in the workflow manager tools and suite, you must define the source of data, what kind of the port for the network. We must describe anything of the activity that can be done. When you restart the program after the test, you can only change the input. One of the standard workflow manager that is called KNIME allows to make the search and to also to produce at the end of the search a report in PDF format. In addition, this workflow, the workflow manager in some cases allows to directly use data mining systems or data mining suite. Then, as you can see, you can merge in an automatic way or semi-automatic way your data to the data mining or data analysis. Otherwise, you can have your specific data system to do. This is very efficient for large data because you can make a search and download of data coming from different, many different databases. You can see here, you can check here. This is a Galaxy. Galaxy is a bioinformatic workflow. It's a free of charge if you are interested to use it. And also CLIMB is free of charge. And it's dedicated to the bioinformatic processing. You then use normal molecular database, metabolomic database, and so on. The other is a specific and experimental workflow that is dedicated to laboratory instrument management. The laboratory integrated LIMS, laboratory integrated management systems, are informatic systems that control simultaneously more than one instrument. Then this workflow is one of the systems to generate massive amounts of data. You can consider to have NMR, microarray, what you want, in an integrated department of biotechnology. All the instruments are integrated. At the end of the experiment, the researcher receives the data from all the instruments. As you can imagine, a big department generates for a same project a lot of data. This lot of data can be used for can be the input for a bioinformatic or other kinds of workflow. Okay, I said in my previous slide, there was the semantic level integration. Semantic level integration, having different heterogeneous database is very critical. And the ontology and semantic web are a key elements in big data analysis of exposure science. The problem, as I said, are the concept and find the relation between the concept. The ontology's definition as conceptualization. Then you have the professor Pasardani said, we make the rule. The rule allows to create to generate a concept. This concept is embedded in a rule. Then we must generate a concept. A concept, for instance, is house. House include a building, artificial building, handmade or other thing. The concept of house is related to artificial building in which a man is living or working. Then this is a rogue example of concept. The ontology, there are a lot of ontology, and bioinformatics has a lot of ontology. The ontology was developed in the perspective to manage big data, because of the increase of experimenting, the opening of new experimental activity was generating more data, big data, and we must find a way to organize, to assess in this data simultaneously in an efficient way. Ontology, we have two approach. One is the ontology alignment. Two ontology. An ontology is a tree, starting from the process to sub-process and having some predicative, some adjective, some sub-concept in general sense. And the ontology can represent the same domain, but they differ. This is important. I can have on EXPOSOME from a specific environmental health perspective, two different structures. that focus that are focused on the same objective. Because one groups, for instance, have a specific point of view, and another groups has another specific point of view. The ontology also are assembled using human expertise. Then the human expertise, if not well standardized, creates some disagreement between the ontology. Then the alignment is similar, is equivalent to align to protein. But instead of align to protein, in this case, the alignment is among the different level of hierarchy of the ontology. An ontology, a cell, for instance. Cell have nucleus as a subconcept, cytoplasm, mitochondria. This is a big subconcept, and you can go down until the molecules. The second is the semantic web, is an extension of VCube, which offers tools in machine interpretable metadata derived from public information and data. Semantic web is an approach to data warehouse information, public, in a perspective to create a consistent and efficient database for exposome when the structured data repository is not available. The aim of semantic web is automatically extract a plausible interpretation comparable to a human process of knowledge discovery. This is then strongly related with the concept that the Professor Pasardani said previously. The veracity or plausibility is a term used by some computer scientists to say is not to say how a result is agree with the experimental data, not in a probabilistic way. This is an example, a schema of ontology alignment. We have two ontology. We can filter two ontology just to reach the level of hierarchy in which they can start. We can check the entity similarity, syntactic, semantic, and structural. Structural and the overall topology of the ontology. Syntactic is related to the terms in each level of the ontology. Semantic is the meaning of each level. The iteration is match aggregation. Exactly similar to the protein, we have a measure to check the alignment. Check for inconsistency repair if there are the lacks in the combined ontology, and then alignment of the sequence. The process is very complex because we are working on three. In a general sense, you can see ontology alignment with a comparison of a family of three. As happens, for instance, in a molecular evolution. You can see here an example of ontology alignment, and the lines that connect the two ontology. For instance, the green ontology is related to the red ontology. The root red ontology is linked to the second level of red ontology, and the other are, for instance, this element of the tree is related to the other tree, to this element of the green ontology. This connection allow at the end of allow to find what are the elements that can be common. What is the effect on the data? You can have the data coming from organized according to different ontology, and you can see the relation between, let me say, gene ontology or chem ontology. Then you can, the alignment allows to find the common point between genes and chem. And at what level? Here you can see that I reported the list, the repository of all biomedical ontology. This slide justifies that we have a lot of ontology, so specialized. The problem is how many ontology we must integrate or use for exposome. All the basic is not so clear. Then in terms to develop the suite, the ideas of one step is to identify for each module of exposome what are their specific ontology available. Obviously, the most famous is gene ontology that cover all the NCBI database, or for instance, gene expression omnibus ontology that link information about microarray. But the array express is more important also because you can consider that we have two ontology for the same experimental activity. Then the problem is, what is the best? The alignment allows to find what are the common points between the two ontologies. Ontology are a key for big data management. Now I would like to show you some example of ontology. In this case, the biological entity, we have tree and barnacle. Tree define that it's a plant, you can see the predicate that connect tree with an high sub-concept level. Tree branch is a tree branch linked to tree and go to the until final biological entity. In fact, anything, plant. On the other side, you in this case, barnacle is an animal, is an organism, and in any case is a biological entity. And on the other side, you can see population, if referred to the human, a cohort is the basic element for epidemiological analysis, of population analysis. Is a panel of subject used to study population, as is in terms of evolution or allelic fixation on other, or for epidemiology to study the morbidity in a specific population. And community that is similar to population, but is different because it refers to, for instance, animals, plants, or other. In any case, the root or the top level is biological entity. Here is most, I guess, is more interesting because is ontology, is the basic ontology, is an example of the ontology used by KB, that is a chemical database of ABI, for chemical compounds with biological activity. As you can see, they start with the right lactic acid or lactic acid, an example, and you go toward an intermediate model, organic molecule entity, to S-block molecular entity, or main group molecular entity, or polyatomic molecular entity, and to the root in some way that is molecular entity. Then using this representation, you can manage, you can access to the data in a relative easy way. You can filter out the data that you need almost in a prototypical phase. Another example you can see here we have 3 plants. Then each one has genes, rice, sorghum, and maize. You can see there is on the top left environmental ontology. Then there is another structure used for environment. There is a trait ontology that is a specific agricultural genetic trait, plant growth ontology, and plant structure ontology. We are lucky because for the plants is very specific. We cannot use it all for exposome. But this slide will show the proliferation of ontology. And if these ontology are embedded in each system for data retrieval, data mining, or data or information retrieval, you can be cautious about the quality of the data that can be retrieved. Okay, this is an example of 2-layer. In this case, we have a simple Excel data that is a or data set, local data set, and we would want to show, to analyze the transmission, location, disease, or in this case, influence in Portugal. In any case, I'll show this example show the intermediate level of exposome, or similar thing can be considered for intermediate level or exposome analysis. This is pure epidemiological, and we have three subconcepts, 3 elements. That is the location, transmission, and the last is the number is an index that indicates the impact on a specific town of avian flu. I guess it is avian flu. Then, or indicate the percentage of morbidity is an index of morbidity. The other is on the top you can see, the biological part of this kind of small ontology, and the top, the transmission mode. The message from these slides is the organization of the hierarchical structure of an ontology is strongly related about the quality of the team that created it. At the international level, there are consortia that working on it. But at local level, when you decide to put together 10, 20 people or more to generate this kind of architecture, that is the really written. Then after implementing XML, but this is the collection of aspects that Professor Basardani said before. The quality is the expertise. The ontology is the way to formalize the expertise on a specific field. And in exposome, as you can imagine, is really in big data plus expert, not so expert, and conflict among the ontology. You can download data that are not so reliable. The other example that I focus on the ontology because from my point of view, I guess is an interesting thing to bridge big data and exposome analysis without repeat the structure, the information that the professor said before. You can see the open talks. You can have an organization that, okay, here you can have an ontology for toxicology. What is the difference between the previous slides? Here is possible to protege is data is a semantic web system. Then it's linked to the possibility to approach the web semantic approach. That is the top level that is available at the moment. You reuse the piece. The other thing is the possibility to reuse piece of term derived by neighbor ontology. Then the system, this approach, consider other ontologies, probably make an alignment and check the consistency about the other ontology, and extract those elements that can be reusable in their toxicity element. You can see here the tox XML structure. You don't imagine how long it is to implement in XML complex toxicology. Here you can see the same in a graphic way, and is the output and the relation about the concept. For example, this is exposure, and this is a species. At the end, is a graphical way. The other aspect of this big data is the visualization. Visualization, in this case, is very, very complex. Then, as this slide is quite similar to some slide of Professor Pasardani. Feature modeling is transformed the structured query into a vector form, easily processable by many machine learning systems. This is very important in the case to use chemical compounds, because the chemical compound has a structure, but a machine learning is not capable to read a 3D structure of a molecule. Training, using a set of selected transformed query as to train, and the remaining part as used to test. And the last is suggestion. Suggestion is equivalent to rule extraction that the Professor Pasardani has described below in the previous lesson. The problem is semantic catching is based, now the slide justified the existence of ontology. Ontology are developed to catch the semantic. The semantic catching require techniques capable to preserve the data. Then the data integrity must be maintained. And it's require two layers, a proxy layer and application layer. For instance, the semantic query is a client-server system, more or less, plus an intermediate manager that is capable to buffer the data between the server and the end user. The intermediate layer is considered only the identical query, is a filter. But the pattern matching and in the intermediate level can have some problem, and you can lose some information. The query suggestion is an approach embedded in a search engine. Google is an example. Then that interact directly with the user to better understand what the user needs. Sometimes in the web search for e-commerce, do you need this good, or are you sure? What size do you want, and the other? And this kind of approach is generally developed with this philosophy. Now the last part is related to the big data in social exposome. Why? Because in this case, social networks, Twitter, Facebook, and other, are central. are also central to manage environmental emergency, and in the EXPOSOME, for instance, to communicate from central website problems about the environment to the inhabitants or people in specific pollution. Now I see in Delhi, in other towns, there is some announcement about the pollution level and or wind or other thing. This approach is used to analyze the network, or the social network, the interaction between population, area, and so on, or to find community detection, to identify groups that can be more or less exposed to a specific pollution sources, or to find the community in which specifically some disease have a frequency higher than the standard value. The network value analysis is relevant in epidemiology and also in the evaluation of hazard, because at this level, on this data, we can start a top-down process of exposome analysis, because they help us to identify the panel of patients, starting with the epidemiological data, and collect all the data only in this specific area or this specific community. Several methods are used for social network, and many of these networks are also used in protein-protein interaction. This interaction for protein-protein interaction, sometimes using software or algorithm derived by social network communication. Social network or swarm computing is derived from 1989, the evolutionary computing, in which many people develop a bio-inspired algorithm to work on optimization and other. Characteristic of social data: very high volume of data, not tractable with standard algorithm. The information is biased by individual point of view and experience. The second point is can also happen in experimental data. The localization of data sources, generation and storage, accessibility. Not always the data are easy to access. For instance, the data of regional health department that I used are private, are high level of security. It's not possible to disseminate. The information is unstructured. Generally, are textual-based data or descriptive statistics. You can have some percentage of rogue statistic. The inference are generated by experience that are sociologists or economists. Then intervene other statistic methods that not always are related with, let me say, biology or epidemiology or other. Then another limitation, another thing that must be considered is what kind of statistic generate this data. Dynamical behavior, because as you can imagine, population moods, tendency change quite fast. You can see here the perception of big data in socio-political organization. Why what is the reason because I put this slide? I put this slide because if in some area, e-commerce, basic finance, the concept of big data is quite well established. As you can see, big data appear in the website, non-governative organization, no. The first that is not, we range from all not, all no, all negation, to the US government that have all yes, they know what are big data, but there is not data scientists in position employed for the big data? No, because they transfer to academy, to governmental research body to do it. It's interesting, for instance, the World Bank. World Bank is a financial organization that has appearing in their big side. It's defined. For the bank, is not significant the concept of big data, but they have position because they pay people here in Italy or everywhere to manage this big data locally. Then it's interesting only to give an imaging about big data outside the science, such as computer science and other. Is not yet well defined. Then this is the last. This is the connection slide that connect all my lesson, and you can. I hope that you have acquired some idea about about big data and how ontology help to big data. The other information about the big data has been clearly described by Professor Pasardani in a previous lesson. I guess that it's better to find a common element that is ontology to manage the big data. Ontology is a big problem. The creation of ontology is a big problem because one can try to do, for instance, for a specific local activity, institute activity, management of the student, what you want. And you can check the level of hierarchy, how to define what are the subconcepts, or what are the predicates that connect the different subconcepts, and how many levels of a subconcept do you have? This is a subconcept is a part of the global meaning of the word of the object. DNA is a molecule, is a macromolecule, is organic molecule, is a macromolecule, is big, or at what level do you stop the hierarchy? The level, as you can imagine, is a critical element for the search, because when I go in gene ontology and select a specific, when I make a search, for instance, in UniProt, I give the name of my protein. The system broadcast in some way using some information. You use this information to go in another database that is related to the protein-protein interaction network. This new database allows to you to have the metabolic pathway and gene ontology terms that are related to those proteins. Then the problem is you can find a gene ontology level and code every day when you make a bioinformatics analysis. The bioinformatics ontology, chemical ontology, and epidemiological ontology are well established because there are big agencies behind them. Other ontologies, such as socioeconomics or other, is a little bit confused the way, because there is not a perception that how to structure the data in this way. The big problem is in the ontology is merge together the ontology and the alignment. This is really complex. The examples are very simple, but if you can imagine to, for instance, to merge together chemical ontology and gene ontology became a real complex problem. On the other hand, as you can could see in a slide, plants have how many ontology there are for plants, and how many ontologies there are for specific biological organism. Then, okay, we cannot use all, but we can select it and check it before to use. Thanks a lot.
Yeah, this one.
This one.
Earlier.
Earlier. This one.
The tree. Yeah.
Okay. Okay.
So in this anthology, from the bottom you can see from tree to tree branch.
Yeah, this one.
That arrow. Yeah, that tree branch is a part of tree.
Yes.
You have written some ratio 1:1, and there is 2:n.
Okay.
So what does that represent?
Because the number in the parentheses indicate the kinds of logical relation. It's 1:1. Okay, it's a univoc correlation because the tree has the leaves and the part of the tree branch. Okay, then is on 1:1. In this case, is 1:n because there is a population is 1 to many logical relation.
Definitely has
Absolutely, yes, exactly. Because you here is not defined elements by elements. It's a one to many that is a very complex situation to manage in a ontology system.
So in the case of 1 to many, it should be 1 to n. Why 2 to n?
Why to n? Because the cohorts can have the cohorts is a panel. I do not read in detail this paper, but a cohort is not a one entity. A cohort includes more subsample. Okay, then it's probably dependent by the dimension or the dimensionality of the cohort used here. Because a cohort can be viewed as a segmentation of a panel into specific age or specific parameters. And suppose that in this case they have used a two-dimensional matrices, then a two more, because each represents something. I do not know on which topic they have used, but probably it depends on the dimensionality of the matrix of the sample that you have used. Here is also here.
Yeah, there are two.
Also here there are two because,
Yes.
because it's an animal and organism. Because probably is that could be also this aspect can be this indication can be related if you have many subjects. It's a code that could be, unfortunately, that I don't put the figure, but we can, I can give the reference. The references is here, and I guess the 2 to n is indicate a multiplicity of elements. Indicate or indicate a multiplicity of relations. Here is unique relation.
I do not know what is the coding or the significance of this approach. I suppose it's only related to the multiplicity of possible relations inside. But I give them the pain. There is not the
So if there are no questions, then we break for the tea.
Yeah.
Outside. Please come back within 10 minutes. I'll let you come back. Thank you.
सर एक बार देखो फिर शुरू किया काम कर रहे थे
क्या
अब देखो
यहाँ पे नहीं, अभी नहीं है। अब बड़ा बहुत बड़ा थोड़ा पहले से क्लियर हुआ और ब्राइट ज़्यादा हो गया है, ब्राइटनेस अब डल हो गया, बस इससे ज़्यादा ब्राइटनेस वो बाकी वो आ जाए, हम चाह रहे हैं वैसे नहीं आ पा रहा, ये क्लियर नहीं आ रही है सब चीज़, इसमें छोटा है अभी।
अब देखिए फोकस हम
फोकस ही ठीक करना है मेन। अब
फोकस यहाँ से clear
हाँ, अब आया,
ये फोकस क्लियर है
ये इम्प्रूव आया, ये नहीं है, ये नहीं है, और करो, ये और आगे करने में होगा कुछ फायदा, डिस्टेंस के चक्कर तो नहीं है कुछ।
देख डिस्टेंस पर तो नहीं
हैंडीकैप है ना, ज्यादा डिस्टेंस का है, इस टेबल पर रख दे तो देखो ज्यादा बढ़िया है क्वालिटी,
वहाँ देखिए
क्योंकि इसका लेंस की भी तो रेंज होगी ना इसकी।
हाँ लेंस तो सर रेगुलर छोटा लेंस
हाँ तो रेंज उसकी कम होगी ना।
रेगुलर हो करेक्ट
नहीं, कम करो, फोकस दूर हो गया, फोकस करो। हाँ
ये फोकस क्लियर है एक जैसे मैंने वाइट कर है ना
पीछे ज्यादा सही था,
हाँ
पीछे सही था, अब पीछे ज्यादा सही था। हेलो, मेरे इनकी आ गई, आ गई। ये लोग नहीं कर पाएंगे मैथमेटिकल, इनको वो दूंगा मैं एसोसिएशन माइनिंग का। आज मैंने लेक्चर में वो करा दिया है, उसने अटेंड किया है, आइडिया तो दिया थोड़ा सा। ओके, हाँ 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 ठीक है, ये उधर ही ले लो, वही ज़्यादा सही था।
वही ठीक है
हाँ, ये यहाँ कम भी हो गया और कोई फर्क नहीं पड़ा, मतलब वहाँ तक ठीक है, पीछे मेरे पास। फोकस नहीं आ रहा इसके अंदर, पास होके भी कट भी गया और फोकस भी नहीं हुआ। फोकस तो भाई आ जाएगा क्लियर। थोड़ा करके। फोकस करो। कनेक्ट नहीं हुआ क्या? इसका है नहीं, ये नहीं आ रहा। राइट, ये क्या टाइम क्या हुआ? ठीक, इधर थोड़ा सा इधर करो। ये करो और करो राइट करो हाँ अब फोकस करो छोटा बड़ा नहीं पाएगा ऐसे बैटरी ज्यादा नहीं if you come up with outside अपना तो अच्छा है okay there are some more you can start now
Okay. I checked the second.
second one
Tutorial, yes, tutorial 2.
Okay. This tutorial is quite different from is more applicative, and originally was focused on big data, but at the end of the history, the lack of true information that can be transferred to you, I suggest myself to change into a more applicative mining information and analysis of chemical data and exposure science. Essentially, this lesson is focused on the problem that each one of us can find in the management and the link of chemical information to biological and biological molecular information for docking, for drug design, for toxicity, and for the more basic level of exposome analysis. That is also the most important because it's the basic knowledge on which we can work. There are two different approaches for mining chemical information. One, information about the toxicity is available, dioxin, other drugs, simvastatin or what you want. Then we know the toxicity and we know also the molecular targets. Then it's quite easy. We can proceed for docking, for designing new molecules or to test different pollutants in a relatively easy way. In the second case, the chemical is suspected to be toxic and no information is available. We have all information about the chemical compound as is. I make the example of phthalate because phthalate is a family of compounds and many of them are potentially toxic, but not information is at the moment available. Here you can see the main data sources that you can access to download, to search and download data set of chemical molecules. You know very well the first, PubChem and KB, and last known probably is the third, the comparative toxicogenomic database. I guess is one of the best tools to assess multiple information about a toxicant. It's publicly maintained, it's possible to download it, and it's possible to link information about genes toward chemicals or chemicals toward genes. Chemicals toward pathway, they have synthesized, they have warehoused all the information about genotoxicity. The system is very good. I am a fan of this database because of a lot of my problem, and allows also to make a small basic filtering of information. PubChem, you can see here, is easy. you probably know very well. And this is the entry page with the form for the query. You can select by activity if exist. You can find the structure search conformer. Then can actually the structural clustering doesn't work. I attempted to do this the last July or the last September to make the clustering of the compounds. The system is out of order because there is not enough power. I do not. You can try if the system is working, but they have some problem with the ICT resource. I do not know. And you can upload and download both chemicals and download data set, and you can FTP all the database. You can see here, for instance, a query for dioxin as what is the entry that you know very well is a textual information. Then even if the numbers are text, are fields in the XML that you must extract for subsequent analysis if you need. KB is similar, okay, and KB more or less contains less. KB contains less compounds than NCBI. Then because they can track, there is a curation higher because check if there is some possible biological activity, and the structure is more or less the same. You can download as XML on SDF. That is important for docking and for visualization in such as PyMol. It's important to focus to types of chemical molecule coding. A chemical compound has a structure formula. The structure formula is represented by a structure. The common formula written in a brute formula or with bounds or other is related to a structural formula. Then the structure is not readable for a machine learning system. Then we need to transform this structured data into a vector or in a machine readable way for the tools for the analysis or also for the research. SMILES, that is probably the widely applied, and this code is used by is recognized by many different tools such as PyMol, Chimera, VMD, and others. It's a method to convert a chemical structure in a Hash string in which there are reported atoms, bonds, rings, aromaticity, and stereochemistry and isotope. Then the code, the string that you have, is so precise for a specific molecule. Then in terms of computer science, is a compact representation of information, compact and reliable. The second, similar, is an international chemical identifier, is layered according to 3 different layers. Main layer, that is the molecule, the charge layer, the stereochemical layer, isotopic layer. This strings is a alphanumeric strings. Is less compact than SMILE, but is defined by International Union of Chemical of Pure and Applied Chemistry, UPAC Association. There is a version, in order to simplify this code, they have created a compact version that is called INCH. That is is a metadata that allows to find the INCH, that allow to download the computer. Is a number that is easy to to manage. You can see the different coding here. You can see this is miles, and this is inch high. You can see how many bytes are required to represent smile or to represent inch high. Normally, the systems accept both, all the three options. However, many of the, if you attempt to make, for instance, a string matching or a pattern matching on different compounds, the use of smile is, I guess, is more compact and more easy to manage in terms of a computational point of view. Another database that I forgot is the Zinc database that contains all the commercially available compounds. You can put Zinc ID. It has a code for each compound. Okay, you can see here the code. You can or you can digitize the smile code inside and then retrieve the compound, and if it's possible, also chemically related compounds. It's the largest database, free. You can access, but the gain is only for the chemical company that produced the compound. You need this compound. You select this compound. You have also the list of the vendors. You can buy the compound. The vendors support this kind of database. You can see here a Zinc database. You can see how many additional information there are. Zinc is not possible to download Zinc because it's only accessible. You can only download the results in some format. I guess XML or XLS or CSV. You can see how many vendors there are, and the vendors gain a lot of money selling this compound. How to obtain the chemical structure for docking analysis? Okay, we cannot start with the simple linear formula. We need a conformer, the 3D structure of the compound. Then the database, PubChem for KB, you select the compound. If there is the 3D structure, no problem. Retrieve the PDB file of the compound, and you are ready to start for your interaction with the target. Otherwise, we have two opportunities. There is a de novo design. You open a window and you design the compound. Then the system, such as also Zinc or other, make the search of this compound. Otherwise, one retrieve the code or inch code and convert this code into a 3D conformer. We have a conversion to PDB file by creating a theoretical model, and you have a model of the compound that if not available. This is an additional database, the option of Zinc that allow for a specific compound. I mistake the position, but make the site perform this site perform all operation Zinc database that are make the decoy compound that are important to verify the efficacy or the activity of a specific compound, randomly extract molecules, or cluster the molecules. But the system broadcasts to you a file or image, but you must offline analyze it. Okay, there are we come back to 3D structure of ligands. The novel design can be performed by Avogadro, that is free of charge, the public domain compound software. That there is with the option of draw structure, and this software import the major formats such as MDL, MOL2, and PDB. The chemical exists, but not 3D structure is available. There is a possibility to use this site that is NCI, National Cancer Institute Translate, that allows to translate let me say a string formula or a plain formula into a 3D. Requires miles. I normally, for my experience, the best is the last one that is maintained on Université de Paris de Diderot. That's FrogDo 2, because this model, this program, generate the model and optimize and select the model after an optimization process. Then, let me say, a little bit more reliable than the previous systems. You can see here the cactus home page, and on the other side, the Frog2 home page. The visualization tools are important for the output, but not only to see the complex ligand target, but also to perform some specific analysis or specific modification. My preferred tools, but it's a personal point of view, is Chimera. Chimera is developed in the USA and is open source. You can download. It's a client server system. So you can download directly the structure. You can modify the structure, and now you can also perform a molecular docking using embedded version of the DocVina. PyMol is proprietary, even if there exists a free option for client. And the difference is in the layout of the screen and how to manage. PyMol have windows for the model smaller than the other. The Chimera has a command line model and that is easy to use and occupy less space in the screen. But VMD and JMOL are simple visualizer. JMOL now is embedded in PDB. When you go in PDB, the possibility to visualize the 3D structure as given by JMOL. These are less used than the previous two. The target selection now. A target selection is can be a protein or can be a nucleic acid. The chemical database given allows sometimes to obtain the molecular target information. If the molecular target is available, you can directly go to the structural database. Otherwise, we go to a step of model generation. Both the step require at the end, before the docking, a quality value control. Why? In the first, I will show in the next slide why. Okay, these are two examples. In PDB, IRAC, a human, that is a primary sequence of aryl hydrocarbons receptor, has only one entry. The human dicer has about 10, let me say, about 10 different structures. If you have only one structure, okay, I take this structure, it can go on. Otherwise, what is the best structure among the 10 NMR, about the 10 different 3D structure. It is important to check what is the best. The best taking into account normally the people search the structure or because is related with the group that prepared the 3D structure, or otherwise select the best solution, or select I never see in the paper someone that select the model according cell factor or other parameters that PDB includes. Normally is resolution and essentially other small elements. The theoretical model generation, we can say directly a model, because now there are database of model in order to join other information to EXPOSOME. And Swiss model repository, this is a big project. Essentially, protein structure knowledge base is the outcome of the structural genomic project. There is an international consortium in which any groups offer the result of its activity. Swiss model repository is maintained by Swiss Institute of Bioinformatics, EXPOSI, that is a pivotal center for proteomics. And the other are generation model. You can use Robetta, or you can use Rosetta Tone, that is a folding systems. And this is an ab initio model, start from primary sequence to generate a 3D model. The other model, homology modeler, this modeler is strictly related with Chimera. Our groups developed Chimera and another group developed modeler, Fire2, that at the moment I hope will continue to work because it's a good predictor, it's a good modeling system. The other are eTasser, that one of the publicly available, because there are some software that are proprietary. Okay, this has been developed by Zhang Group, University of Michigan. It was always in the last context for protein structure at high level of quality, and superfamily in reality is another database in which the proteins are organized by family. It's an ontology, because there is the class, subclass, and so on for proteins. There are different kinds of software. Some of them can be used by through the web, SwissDoc, HADDOC, that is a very good system for modeling if you have structural experimental data. And FireDoc, that is a tools that is installed in an Israel website. You can use a PatchDoc. FireDoc is a suite of two programs. You can submit your request and then broadcast in a zip format the result, and then you can analyze offline or check the quality and put this result in your local database. Or Autodoc, there is Autodoc Vina that some of you use for other application, but it's a very good system. Doc, Flex is commercial, and Gold is commercial. As you can imagine, Autodoc and Doc are the most favorite because are free. They have a great advantage to use it. Okay, you can see here an example of what is possible to do with the chemical toxicogenomic database. is an example I provided to check the chemical interference with transthyretin and amyloid. I submitted transthyretin to toxicogenomic database, and I have obtained a results. Then after, you can see here the and after I have selected, I submitted amyloid, and I've selected the chemicals that interfere with amyloid. The Venn diagram show there are 44 chemicals here. You can see here chemicals related to transthyretin, chemicals related to amyloid protein precursor. And you have the list. In this way, you have a preliminary list of potential chemicals that you can use for toxicity, for in silico toxicity test by interaction. You can see as I said, the two on page of the PatchDoc and FireDoc. You can run PatchDoc. At the end of the run, the server broadcasted the result to you, saying to you if you want to use the other. The link is directly made by you as a reply to the preliminary results. This is the result for an example for protein from some of these common interfering chemicals on different chain of transthyretin. Transthyretin is formed by 4 chain, and this is the PDB structure. We have had the PDB structure. This result has been obtained by is obtained using PatchDoc, FireDoc, and you can see the lowest contact energy. What is the contact energy? The contact energy at the end of the history is the strength of interaction between a chemical and its target. You can see for the other the minimal and probably the maximal. No, the maximal value is there. The number of contacts is the number of potential atomic interaction or functional group interaction between the chemical and the target. And as you can see, there are some small differences among the four chains. Then what is the problem? The problem is that now we have some information about the binding that we can collect, but we cannot, we must transform this data into data that are informative good for an application. All this procedure is fundamental to go on the next step, that is not in this tutorial, that is the quantitative structural analysis and quantitative structural relation, QSIR. That is the possibility is a data mining in general sense. You make this analysis for 1,000 compounds. Then after you must decide to what are the features or what are the chemical characteristics that influence a specific contact energy or binding energy. Then you can, for instance, there are in the GCA imply 6 different parameters: van der Waals, attractive van der Waals and repulsive van der Waals, surface area, and other. Then, if you consider this parameter GCA as a response variable, you can use the data obtained by docking as a feature that define that affect the specific response. You use a matrix with your data, and you can use different tools to predict or to correlate the toxicity. At the end of the, to correlate these variables, independent variables, with the dependent variable delta G. Is a common approach for docking. The docking is a step forward, but my interest was only to show you what are the tools that are available to prepare a compound. The docking will be part of the next lesson. Then I only would like to focus on the, let me say, on the repository, on the starting point of docking, because the how to search the data, how to warehouse this kind of data, and how to fill the lack of structure if in your data if occur. The structure of 3D of a useful format for docking or for other kinds of interaction methods is important, because otherwise you can reject, you can remove a lot of new compounds. For instance, dioxin or other compounds like this is easy, but you consider that 1 billion of new chemical entities go into the market, they go into the database, and the problem, not all are recorded in PubChem or KB, or zinc all, but the other not. And the problem is how to surf internet, how to make a search about the research, about the sources for your data. As a starting point for a workflow could be the integration of this kind of data in order to merge together, to warehouse locally all the information about a specific set of compound, or a specific set or compound specifically identified in a pathology or other thing. In this case, the two proteins are related to Alzheimer's disease. Then these compounds are probably related on them. However, the problem the problem of starting point is what you plan to do. In exposome terms, the idea to start from top level or bottom level is important, because if I have epidemiological data, cancer or what you want, I can select in this the kind of database a search on compounds directly. Benzoapyrene is well known, or other contaminants are well known for their carcinogenicity. But if you start from the bottom, you want to link this data to a disease, you using CTD database, you can is easy, because you select the disease, you can have the genes related to those diseases. We can add, there are other databases that can be used, such as toxic drug bank or PharmaGKB. I'm sorry, I forget the PharmaGKB, because PharmaGKB is a quite exhaustive system to link pharmacology, molecular biology, genomic, and genetic. I forget it because recently I am using only on structural analysis of nucleic acid is enough, this thing. Essentially, PharmaGKB is fundamental because you can directly link, you can directly point or extract information from multiple different facet of the problem. Other databases are like the database about exposome or chemical toxic database, EPA, Environmental Protection Agency databases. But for chemical, these, including drug bank, pharmacy KPB, you have enough an enough exhaustive framework of the chemical information availability. The problem of 3D structure and the modeling of the 3D conformer is a big problem. Another, because in many cases, the 3D structure does not take into account the stereoisomeric property of the system. Okay? Yeah, if I have a molecule, in which way Chimera or PyMol identify if the molecule is a stereoisomer or not. You have the 3D structure. This is a gap. Initially, you can consider the structure as the model, as the program will be generated. In this case, even if a SMILE consider stereoisomeric property, the graphic, the 3D graphics, create a problem because normally the graphic is in a 3D, Euclidean 3D space. And in which way I can put a stereoisomers in a 3D space in which there are the bonds. There are some problems to identify the stereoisomer property. But in a first phase, the structure are quite good. Another question that coming from the structural property of the chemicals is related to the functional groups that they have inside. Pollutants or compounds that can have an effect on a specific molecular target has show in the molecules a specific functional group such as methyl, carboxyl, oxydyl group. The difference, the presence of one functional group or another on a molecular backbone, on the same molecular backbone, it can impact the binding efficiency in a high way, or can modify, for instance, the regions, the residues involved in a possible binding. How to decide what are the more critical functional groups is an object of chemoinformatics analysis that, in another way, is essentially an aspect of machine learning or classification of what you want. Because we must select your data set, analyze the data set as chemical, even in this case, according specific data transformation, and you can use it to check what are the groups, the functional groups inside. Then linking is possible to link a similar parameter of content energy with the functional groups, and in some way we can consider to have generate a small rule. It's toxic if there is methyl group and or oxydyl group, because the binding efficiency is higher, or inhibition constant is higher. Inhibition constant is not possible to compute with this on web. You must compute offline. Autodoc allow to compute directly this constant. You can correlate the inhibition constant with this parameter and the chemical parameter. This is the thing that I am now attempting to do for a specific pro target. that I am so confident that the system working well, almost for this target, because we do not forget that biology is high variability, and for one target, the docking, the system of docking has an average percentage of performance of 70, no more than 70%, because the impact of the structure and protein structure and compounds is very, very high. Normally, the analysis, the performance of docking software is performed on different set, and on one set it's possible that a method working better than another, and so on. Then at the end the docking and the results of let me say of predictive inhibition parameters or activation of, sorry, in general sense, the interaction parameters are estimated, and in terms of in a exposome perspective, do also the choice of this approach and the improvement of this approach affect in a dramatical way the definition of toxicity, because the toxicity is there. Then you can go to you must validate by high throughput screening. You must directly pass from the silico to high throughput screening. Otherwise, in terms of exposome, we cannot implement, or we cannot add this information to a more global general system. I guess to offer, I hope, quite clear view about the problem that I have found, and I transmit to you in order to avoid the same problem and the same loss of time to solve some problem. And thank you for your attention, and if you have some questions, I am here.
Officially, in my career, I have started with the DNA.
Originally, I would like to analyze the fine structure of regulatory domain promoter in the DNA by using neural networks. Officially, we have done this work 26 years ago, 27. It was the first attempt to use a specific kinds of neural network for biosequences. After, the problem of promoter is an example. I decided to select the promoter according to literature. The data collection and the check of the experimental data for 400 promoter using the old literature require more or less 1 year. Because no information about the functional motifs such as data box in the promoter. The idea is to find a combination, but in order to validate the system, we need a sample of really experimentally validated motif. 1 year. Then after decide to change a little bit, working on mRNA, because it's a little bit clean. And on the other side, because the analysis promoter, if you check on the database, is still one of the dark side of the genome. Even if chromatin immunoprecipitation has increased the performance, the fine structural promoter is still in progress. No one knows on a specific cell line, a specific core promoter what is, except SP1 as defined. If if I would like to identify the combination of motif, functional motif in a promoter in a gene A, okay, normally it's difficult to say how many motifs there are inside. They said there is a promoter. If you go on ensemble or other, they give the information about the region. But what kind of motif there are inside? No, it's difficult. Then without knowledge about transcription, it's difficult to engineerize in a stable way something. Because the process of transcription translation is parallel, then it immediately start the transcription and immediately start the regulation of the transcription by non-coding RNA. Then the simulation of this feedback is very complicated. And the attempt to do this, I became very depressed because the problem was very, very complicated. Then after, the money is important, and I have worked on text mining. This is the reason because I am going to use always neural self-organizing maps on text mining in order to extract chemical constant from for kinetics for system biology modeling. In order to find, initially I made by hand the search parameter, and in order to find 4 or 5 Michaelis constant, I spent 3 months and 400 paper. I still have the printed version of the paper. But at the end of the history, it's not enough to model it and finish also the process. The guys, it's not possible to integrate the proteomic modeling with the neurophysiological modeling, and it's stopped. Now I am working on pharmacogenomics and toxicogenomics, restricting a more clear way using RNA that are quite well sequenced, and the chemicals are relatively easy to do. Then using chemoinformatics or biochemoinformatics, using machine learning for predicted toxicity. Predicted toxicity take into account the SNPs, because we don't take what happens in the docking if I insert SNPs inside. It's easy to do because now, unfortunately, the database are relatively well integrated, and we can download enough data if compared to 20 years ago. And then this is actually I am working on interaction of pollutants on RNA. In particular, non-coding RNA, and on the enzyme that's working on RNA processing, because are in a key place for gene expression in terms of exposome, for instance, are the first mechanism that can be modified when an excess of pollutants come into the cells. I am very happy to have started a collaboration with NIRI, because now the information switch from India to Italy. They have experimentalists, and they have a microarray. I never used it before, analyze microarray, and then I am going according their suggestion, what they need. We develop a software or analyze data according what they want analyze. But only now. 20 years ago was better. I am too old. Thanks a lot.
there is no space for, but also in the legend, there is no information about the probably GIAN everything they are in the data. It's better. But I'm not so sure because Sam is a college and so correct for what is the need. Probably someone has supported this job. The thing is first they come human. When the human problem is solved, but the government has not the government is said, okay, let me in the process, okay, give me more data. In this case, the data are distinguished what is the organization of the that's not what they mean because and in this case it's my feeling that I prefer into other kinds of concepts such as it's with ontology, unfortunately, if you the system all is they come then if they fail or if there is not so correct it's not possible for exposome to have an infinite number of ontology methods that are relatively small number. You have more ontology than them. At the end. I can make an ontology for solar. I can make a theory of now.
Several ontology for a
The last that's mine. The thing I am only is I have some form that I have, but I can do I can say from the additional materials to the professor if you want, because usually the thing was programs running in Arab, and then they are with me. The text mining has been the shift by time. As you can imagine, I'm working more or less on one. Then the problem is how to schedule the activity. I can show all the papers that we can control the quality. About the ontology, yeah. procedure that I am using now, actually I'm using, as I said, in this case, I'm using self-organizing method to rank, to study the individually possible toxicity relates. They have ranking what I'm doing before coming here is to extract the tool. But at the moment, I have some presentation that for papers 10 years ago on text, in which we use some, we extract some. In this case, the process is not a simple one song. It's a classifying the sample and using different metrics and specific intermediate reporting system to check the quality of different, to merge together the results of different. In this class, combining some cognitive systems, you can extract later and intermediate level to show the is it the last lecture? Is it the system work? The only problem is the project is finished. And no one has maintained the software. Then after on my machine, switch off the server because it was a hacker attack from sensor. It became neural for sexual size and detection of the machine. And the program, I look at the program and one of the things that we plan to do with some colleagues was the program for me, critical biology program have the data. If you have the data, you can go in mathematics, you can go what. If you don't have the data, you can hope to have the. This is my case because the problem is there. Now it's not a joke. I continue slow with this. It started when I started to work with me. It's a clear with this thing because otherwise I have landed with the genetic department of an hospital. Okay, I send you the data. Okay, I send you the data. You cannot stay 1 year without the data. The other problem, the other is the project with the regional different. This is a good approach to finding the molecular impact of multiple substance addiction. Okay, the data here. Now there is the last step to extract the rule. How happen if okay, if you take cocaine and crack simultaneously, you see clear. But at the end, for a machine, not. For the system, not. The system does not know that two drugs are so heavy. And you have the collection with the all inside how to extract the root. What is the impact? The request of the system is what is the impact of addiction on immunity and HIV and tuberculosis, on comorbidity. This is a problem that can occur in exposome. Depended by the drug, which is substances, you shift the forecast, more or less. The problem is for me is the fact. Absolutely. And as you can imagine, human resources. No more because a computer now has so power to run. I make a matrix of 10,000, 20,000.
is the week to 6 days, almost 1 day in my house. Is that? Then and after, I guess after retirement, back to job.
You can almost always get
The problem,
You will wait for the
the problem is that is how to patch. One of my nephews, yes, other than English, there I never said something, some compromise there. Then the problem is, yes, they have asked for the class. I have a student from the engineer, but it's not so good. He made the DSP analysis for ribosome or the knowledge, the basic knowledge is not so high. I do not know the other professor, but the professor does not know what is interpretive range. Okay? And I'm talking about finite space. We're talking about basic statistics that the gas can do of high school, more or less. You understand what kind of people
फोटो अपलोड करने के लिए नेचर अपलोड फिर वो अगला ऑप्शन आएगा मैनेट पे जाना
ये इस पे टाइम डाल दो कल का,
कल का डाल दे
कल सुबह 10 बजे और इंडियन टाइम डाला, वो पीएसटी डालता है, यूएसए का टाइम ले लिया ना उसने, तब टाइम
इसलिए ये जरूर
तो आप नेक्स्ट सेशन अब कल यूएसए का टाइम
ये चेक कर रहा था कि क्वालिटी हो सकती नहीं,
वो दूसरा